back to you with a new video. If you like our video, please share to your friends, subscribe, and don't forget to click bell icon. Here I am here to tell you about balancing of chemical equation. Balancing of chemical equations, as we have studied, there are different types of changes and how to write exothermic, endothermic, and all we have learned. Now let us see what is a chemical equation. What is a chemical equation? A chemical equation is nothing but the chemical reaction. The chemical reaction. Chemical reaction. What is a chemical reaction? Any two chemicals, if they combine, any two chemical or elements, when they combine, it is a chemical reaction expressed by writing what? Writing symbols. What? Symbols or molecular formulas. Molecular formula. Chemical reaction expressed by writing symbols or molecular formulas of what? Of what? Shall I write my name or your name? No. Of reactants and products. Of what? Reactants and products. What are reactants? Which will react a substance, which to combine to react. Reactants and products is called as what? A chemical equation. The chemical reactions expressed by writing symbols or molecular formulas. What? Molecule, what are two atoms when they combine, it is called as molecule. Like H2 plus O2 gives rise to H2O. Mg plus O2 gives rise to magnesium oxide. Isn't it? Writing molecular formulas or symbols of what? Reactants and products. It's called as a chemical equation. It's called as a chemical equation. In solving chemical equation, when you write, when you write something, molecular formula if I want to write, formula if I want to write, see, Mg Br2. If like this it is there. It means that Mg plus 2 Br combined to form what? Mg Br2. Combined to form what? Mg Br2. Another example. Mg plus 2 plus Br2 combine. Two atoms of Br combine to form what? Mg Br2. And next H2O is one molecule. Water is of, this is one molecule, isn't it? Means one hydrogen, two hydrogen atoms, one oxygen atom combined to form water. Let it be ion. See, NaCl is there. Na plus Cl minus, you should not write it. One unit formula, NaCl. NaCl. And next, magnesium oxide, MgO. Like this you are supposed to write it. Like this you are supposed to write. And why we need to balance? Why balancing? Why balancing? According to the law of conservation of mass. Law of conservation of mass. What it says? It says that, see, in reactant side, if oxygens are 2, in the product sides also oxygen should be 2. If in the hydrogens, in reactant sides, those are 2. In the product side also it should be 2. If in HCl, suppose in zinc and HCl you have saw, zinc plus HCl. How many zincs are participating? Only 1 or 2. How many are there? The mass of reactants should be equal to the mass of the products. Mass of the products. The atoms is the smallest particle, Atoms is the smallest particle. So number of atoms on the reactant side should be same as the number of atoms on the product side. So let us start. Let us start how to balance a chemical equation. How to balance a chemical equation? If something given here, H2 plus O2 will give rise to H2O. What, according to law of mass conservation, the number of atoms present here, the mass of the reactant should be same as the mass of the product. After forming the product also, the atoms neither be created nor be destroyed. Here see, here H2O2, here one atom of oxygen has destroyed. So it's an unbalanced equation. It is an unbalanced equation. This unbalanced equation like this, without balancing, number of atoms here is not equal to here. It is called as a skeleton equation. What is called skeleton equation? What it is called? Skeleton equation. Unbalanced equation is called as skeleton equation. Now see, how to balance this then? How to balance this, as we have discussed already, isn't it? How to balance this? You are not supposed to touch the subscripts. First, whenever they give a formula, write down the chemical formula as written. Done. First step done. What is second step? What is second step? What is traditional method I am saying you? I will tell you later in an easy way also. Second one. Write down elements. What are the elements participating? Number of atoms, LHS, RHS. LHS, RHS. What are the elements here? Only two on elements H. Oh, only two elements. Done. How many atoms are there here? On right hand side H, 2. Here 2. No problem. Here oxygen 2. Here 1. Isn't it? So if anything is here, so I will say that. If I will tell you it. So I need to add number of atoms on the left hand side should be equal to the number of atoms on the right hand side. The masses are same, isn't it? After the reaction or before the reaction, they should be same. And the atoms neither be created nor be destroyed during the chemical reaction. How many atoms are there in the left hand side? On the reactant side, those many should be there on the product side also. So here into 2 I have to do. What I need to do? Into 2. So write down H2 plus O2. Shall I add? I should not disturb here. I should multiply 2 to what? On the right hand side or the left hand side? On the right hand side. I have to write here? No. It's a big crime. You have to write here. You have to write here. Now, again, elements. LHS, RHS. Elements, LHS, RHS. Then write down H, O. Here 2. Oxygen also 2. Done. Hydrogen here. Previously it is not there. That's why it is 2. Now it is there, isn't it? We need to multiply this coefficient with this subscript. 2 2s 4. Here. 2 2s 4. 2 1s 2. 2 1s 2. Again a problem. Where? 4 2. I need to, how much I should multiply to get here 4? Into 2 if I multiply it's enough. Into 2 if I multiply it's enough. See. H2 plus O2. Where? On the left hand side only. On the reactant side only I need to. So 2 gives rise to 2H2O. Now you multiply. This will be your balanced chemical equation. That will be your balanced chemical equation. And one more also I am going to tell in this traditional way only. And later I will tell you one more method will be. While you are balancing, these steps are okay. But while you are balancing, you need to remember some points. You need to remember some points. What are those points? First, you need to follow some sequence. You need to first balance metals. Next, you need to balance non-metals. Next, if any oxygens are there, you are supposed to balance oxygens. If any hydrogens are there, you need to balance that hydrogens. You need to balance that hydrogen. So what you need to do first? Metals, non-metals, oxygens, hydrogens. Metals, non-metals, oxygens, hydrogens. So whatever the changes subscript to the subscript, you are not supposed to touch. To the coefficient, whatever you touch, you need to again go for the first step again. If you change oxygen, if you change hydrogen, if you change non-metals, then metals, non-metals, oxygen, hydrogens, metals, non-metals, oxygen, hydrogen, MnOH. MnOH, metals, non-metals, oxygen, hydrogen, metals, non-metals, hydrogen, oxygen, metals, non-metals, hydrogen, oxygen, hydrogen. Now let me say you some examples regarding this. What examples we will take it? Fe2O3 plus aluminium. Fe2O3 plus aluminium will gives rise to what? Fe plus what? Al2O3. Fe plus Al2O3. Fe2O3 plus Al will gives rise to what? Fe plus Al2O3. Fe plus Al2. Metals are there? Yes. Ferrous oxide, isn't it? Fe. Iron is a metal. Al is a metal. Fe is a metal. Al is a metal. Oxygen is there. Hydrogen or the fluid. First balance start with Fe. Fe. How many are there? 2 are there. Here how many are there? Only 1. 1 into 1. 1 into 1. Only 1. So I need to add where? 2. I need to multiply 2 where? On the as it is less. 1 into 2. 2. Done. Here again metals. 2. 2 done. Next metal aluminium. Al, isn't it? Next metal is aluminium. Al. Here how many? Here no subscript, no coefficient. So you need to estimate now 0, 1. 1 into 1. 1 into 1. 1 into 1. 1. Here 1 into 2. Nothing is there. Isn't it? It means it is 1. 1 into 2. Nothing is there. It means 1. It means 1. Nothing is there. It means 1. 1 into 2. 2. Here 1 into 1. 1. So I need to multiply here 2 to get balanced. Now see, this here 1 not there. For your understanding I have written. Yeah. Fe 2. 2. 1 into 2. 2 atoms here. Here 2 done. Next Al 2. 2 done. Done. Here 3. 3. Hence this is balanced. Metals, non-metals, oxygen, hydrogen. Metals, non-metals, oxygen, hydrogen you need to follow. So that you will get very, very easily. Whatever. This is our third example. C plus O2 gives rise to CO. C plus O2 gives rise to CO. So metals are there? No. Non-metals are there? Yes. C is a non-metal. Oxygen, hydrogen is also there. So leave it. So here 1. 1, nothing is there, it means 1, isn't it? 1 into 1. 1 into 1. 1 into 1 is 1. Here also no coefficient. Subscript no. So it's 1. 1 into 1. 1 into 1, 1. Here oxygen is 2. Oxygen is 2. No hydrogen, right? Only oxygen is there. Metals, non-metals, oxygen, hydrogen. Metals, non-metals, hydrogen, oxygen, hydrogen. Now 2. Here only 1. 1 into 1, 1. I need to balance here. I am not for only no. Can I write here? No, I should not write here. Can I write here? No, I should not here. This is 1. Yes. Now you need to write here 2. Now see here. 1 into 1, 1. 1 into 1, 1 here. 2 into 1. 2 into 1. 2. So I need to change it. 2. Here oxygen, okay, 2. Done, okay. I need to change here. So where I should write? I should write here? No. I should write here. So 2. But this 2 does not belongs to this because plus is there in the middle. So it does not belongs to O2. If plus is not there, then it belongs to both. If plus is there, this is different atom and this is different. Isn't this is different atom, this is different atom. These two are molecules combined, they combined, isn't it? So these two are same. This coefficient belongs to these two, but plus is there, no, it does not belong. It is individual. So 2, 2. 2 carbon, 2 into 1, 2 carbon, 2 into 1, done. This is metals, non-metals, oxygen, hydrogen. Metals, non-metals, oxygen, hydrogen. This is the method you need to follow. Hydrogen. Metals, yes, there. Copper, copper. Non-metals, yes, nitrogen, there. Oxygen, there. Hydrogen, there. Now, let me see. First metals, 1, 1. 1 was 1, 1 was 1, done. Next, non-metals, 2. Non-metals are here 1, here 2. 1, 2 is 2. Here 1, here 2. So, I need to change this. I should not write here. I said you already here I should write. Done. 1. Metals again. From metals again. Metals 1, 1 done. Non-metals 2, 2 done. Next, oxygen. How many? 1. 1 done. Hydrogen. Next is hydrogen. Metals, non-metals, oxygen, hydrogen. Hydrogen, how many? How many hydrogens? 2, 3, 6. How many hydrogens? 2, 3, 6. How many hydrogens? 2, 3, 6. Here, 2. So to make it as 6, I need to multiply with 3 to the coefficient. Now I need to add 3 to the coefficient. So that, see, Cu. Again metals. Come from whatever the change you make, metals. Cu, done. Next, non-metals. Non-metals, how many? 2. 2, done. Again, oxygen next, 1. Here, but here it is 1, 3 is 3. So make it as 3 here. Again from metals. Metals here. 3 belongs to this copper also. Cu belongs, 3 belongs to Cu also. Again here you add, you multiply 3. So done again. Metals, balanced. Non-metals, 2, 2 balanced. Oxygen 3, balanced. Hydrogen, 2 3s. Don't add 2 plus 3, 5 you don't do. 2 3s, 2 3 6. 3 2 6. So everything is balanced. Everything is balanced. What metals? Metals, non-metals, oxygens, hydrogens. Metals, non-metals, oxygen. Example. Here, metals, non-metals, oxygen, hydrogens. You know na? Metals, yes, it is there. Metals, there, yes. Aluminum is a metal. C is there. Non-metal. Oxygen there. Hydrogen there. Done. In a way, we will do it. Here, how many nothing is there in the, this means it is 1. It will be not written, but you need to assume it is a 1. 1 force 4. 1 force 4. 1 force 4. There. Where is aluminium? Here. 1 1's 1. 1 1's 1. So what you need to do? You need to multiply with the 4 there. Yes. 4. Done. Now, metals. Al. 4 done. Next, coming to the non-metals. C. 3 is there. See how many are there? 3. Here 1 is there. So put it 3 here. Yes, done. Now again come from metals. Metals 4 done. Non-metals 3 done. Next go for oxygen. Oxygen there. What? Oxygen is 3. No. 4, 3 is 12. Oxygen is how much? 12. Here only 1. You need to multiply with 12. You need to multiply with 12. Next. Again come from here. Metals 4. Aluminum 4 done. Carbon 3 done. 12 2's. How much? 12, sorry. Oxygen rate 12 ones. 12 ones. 12 oxygen. 12 ones. 12 oxygen. Next hydrogen. 12 2's 24. How much? 12 2's 24. Here hydrogens are in this and this both. So 3 4's are 12 plus 3 4's are 12. 3 4's here 12 into 2 is 24. Here 3 4s are 12 plus 4 3s are 12 hydrogens, 24. So hence balance. So now metals not there. Non-metals, yes, carbon there. 2. 2. Here 1. 1. This that does not belongs to this. Subscript does not belongs to both. Subscript, it belongs to its individual atom itself. No, it does not belongs to this. So 2. 2. 2. 2. But this coefficient next, oxygen. Oxygen, non-metals over. Oxygen next. 2. 2. Oxygen here. 2 2s 4. 2 2s 4. Plus 1 5. 4 plus 1 5. Oh, I should do here 5. But there is, in 2 you will not get 5. What to do now? Shall I give up the problem? We should not give up the problem till end. So what shall I do? Whatever the odd number I want here, I need to multiply with that. But to the subscript, I need to divide it by subscript. I want 11 here, write 11. By this subscript 2. Got it? Now, it's in a fraction form. Very difficult to do that and to balance it, to check also. So multiply whole with the 2. Into 2 you do it. Into 2. So what happens? 2 C2H6 plus 5O2 gives H2. 4 plus 2H2. 2 into 2. 2. 2 into 5 by 2. 2 to get cancelled. 5. 5 by 2 like this you are going to get cancelled. 5. Now 2 2 is 4. 4 CO2. 2 1s 2. 2. Now see. 2 2 is 4. Non-metal. 4 done. Oxygen. 5 2 is 10. Oxygen. 5 2 is 10. Here 4 2 is 8. Plus 2 1s 2. 10 done. Next hydrogen 6. H6. Hydrogen is H6. H6 or 2 6 are 12. H6 or 2 6 are 12. You should not take only this. This belongs to this and this both. So 2 6 12. Hydrogen how much? 2 6 12. Here hydrogen 2 2 is 4. 2 2 is 4. Oh. Again I need to. What I need to? I need to multiply with the. I should get 12, isn't it? So 6 I need to multiply. Now again second from metals. 4. 4 no problem. Oxygen 5 2s are 10. Here 4 2s are 8. Plus 6. 8 plus 6. 6 1s are 6. 8, 9, 10, 11, 12, 13, 14. 14 I should get. So what I should do here? Again, to get 14 it is easy, isn't it? To this you should not count. For this only you should. 5 is there no. 14 means 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Teacher, I write here 6, then it will become 14. No. 7 you need to multiply. 7 2 is 14. Now again from non-metal 4. 4 done. Oxygen 7 2 is 14. Here 4 2 is 8. Plus 6 1 6. 8, 9, 10, 11, 12, 13, 14. Oh, plus oh, 14. Done. Hydrogen 2 6 12. 6 2 is 12. Done. Balanced. Don't leave your hope till last. If you have any odd number, I said no. Write like this. So it will be very, very easy. Seventh example. In this metals are there. Yes, Fe is nothing but iron. Metals is there. Non-metal, yes, S is there. Oxygen is there. Hydrogen, not there. Don't leave it. First, check with metals. Fe, only 1. 1 into 1, 1. Here 2. Here 2. So, 2. 2. Now, 2. 2. Done. Non-metals, you need 2. 2 2 is 4. 2 2 is 4. 2 2 is 4. Here only 1. So, 2. Now, metals again. 2. 2 done. Non-metals, 2 2 is 4. 2 2 is 4. 2 2 is 4. 4 I need to. 4. Done. Understood? I have multiplied only 2. But this 2 does not belong to this now. You should not do like this. This is different and this is 4. Here 2 2s 4. 2 2 2s 4. Done. Next, oxygen. Only one is oxygen. 2. O2. O2. How many oxygens are there? Here 2 is there. Here 3 plus O2s are 8. 8, 9, 10, 11. No, odd number. What I shall do? Now, I said no. Any odd number comes, I need to multiply, but I need to divide with the subscript 2. Subscript 2. Again, let me check from metal. Metals 2. 2 done. Non-metals 2 to the 4. 4 done. Oxygen. Okay, this is in the fraction form, na? In the oxygen, I can't count like this. Again, multiply this whole one with into 2. So that I should not get this fraction. 2 2s 4. Plus 11 by 2 into 2. Cancel. 11 over 2. Gives rise to 2 Fe2O3 plus 8 SO2. Isn't it? Again check. Metals 4. 4. Here 2 2s 4 done. 4 2s 8. This 8 is done. 11 2s 22. Now it becomes 11 2s 22. Now oxygen, right? 2 3 6 plus 8 2 16. 16 17 18 19 20 21 22. 22. Then this will be your balance equation.